Yo, yo, do you hear me? This is Section 5, 6 Inequalities and 2 Triangles, coming at you live from OHS High School. This is Mr. Lane. Your objective is right down there. Again, you can read through the Y. Your number 5, make sure you answer that in your notes, and always be looking for that secret word. Who knows what it's going to be this section and where it's going to come. So make sure you're paying attention. Get that first one to me, 2 points. Alright, we've got two major theorems on this one, and they're actually related to one another. The first one is the Hinge Theorem, which basically says if we have two sides of one triangle that are congruent to two sides of another triangle, and the included sides are not congruent, then the longer third side is across from the larger included angle. So this is based off of kind of a door hinge, or just any type of hinge, I guess. So let's do this for a second. Alright, so these two sides do not change lengths. So we can make a triangle that would come right from the endpoints of those two segments. And as we widen this one out, notice that that third side that we would draw in there would become larger. So if we have two sides that are congruent and the angle that is not congruent, then as we widen out that angle, the longer this third side's going to be. So I think I got a picture here labeling the two. The angles actually shouldn't be marked congruent in there. So I'll put two marks over here and just one mark over there. But anyways, whichever one's the larger angle, the side opposite from that is going to be the larger side. So this is saying if angle A is bigger than angle D, then BC would have to be longer than EF. Okay, and then the converse of that is going to go kind of the flip of that. It would be if two sides of one triangle are congruent to two sides of another triangle, and the third sides are not congruent, then the larger included angle is across from the larger side. Okay, so again, these two shouldn't be marked congruent. This says that this is larger than KL, or JH is longer than KL. So therefore, this angle J would have to be larger than angle M. So again, pretty closely related to one another. But that's our major concepts. Let's see how we can apply those in this lesson real quick. So we're supposed to compare, let's see, BAC, this angle right here, with DAC, so with this angle right here. So notice reflexive property tells us that AC is shared in the two triangles. These are marked 4, AD and AB are both marked 4. So we got to compare these sides opposite or across from the two angles that we're comparing. The 7 is bigger than the 6, so therefore we could say that the measure of angle BAC is going to be bigger than the measure of angle DAC. And that's the Hinge theorem. Alright, let's move on here. We're supposed to compare EF right here with FG. Again, I see that we have the reflexive property. I see that we have both 7 degrees, or sorry, 7 marked for lengths here, which make H a midpoint also. And then we've got a linear pair sitting right here. So if this is 82, 82 plus what equals 180? Well, I think that would be 98. Then for this angle. So we're supposed to compare the sides opposite of these two angles. And if the larger angle is 98, then that means that FG is going to be bigger than EF. Okay. Alright, so we're supposed to find the range of the values for K. So K is right here. Again, it looks like we have the sides marked congruent and reflexive property. And then we know that this angle is 38, and we're supposed to find what K could be. Looking across from the two angles that we're comparing, it looks like the 19 is going to be bigger than the 18. So that means that the 38 degrees is bigger than the 5k minus 12. Alright, so let's solve this real quick by adding the 12 to both sides.